Imagine this, you open Instagram, your profile loads instantly, your session is recognized immediately, your feed appear almost magically, you click like, the count updates instantly, no waiting, no loading spinner, just speed. Behind the scenes, there is a good chance Redis is involved. Redis is used by companies like GitHub, Stack Overflow, Pinterest, and many others. But here is the interesting question. Why is Redis so ridiculously fast? How can Redis respond in microseconds while traditional databases often takes milliseconds? The answer lies in one simple idea. Redis avoids the slowest thing in computing, disk access. Let's understand why. The real enemy is disk. Let's start with the thought experiment. Imagine you ask someone, "What's my phone number?" If it's in their memory, instant answer. If they need to find an old notebook, walk to the cupboard, open it, search through pages, then answer. Much slower. Computes face exactly the same problem. RAM is memory. SSD, HDD is the notebook. Typical access times. RAM takes around 100 nanoseconds. SSD takes around 100 microseconds. HDD takes around 10 milliseconds. Notice something? Disk is not 2x slower, not 10x slower. It's often 1000 or even millions of times slower. This is the biggest reason Redis is fast, because Redis keeps data directly in RAM. Next is Redis' biggest secret lies in everything is in memory. Traditional databases reads from disk, write to disk, update indexes, manage storage structures, handle page reads, handle page writes. Redis keeps most of that. When Redis starts, it loads data into RAM. After that, read request happens directly from memory. No disk lookup, no seek operations, no waiting. Imagine two libraries. Library A. Every time you need a book, you go to the warehouse. Library 2. Every popular book is already on your desk. Which one is faster? Redis is library B. Next point is Redis uses simple data structure. Many databases are built around complex storage engines. Redis keeps things simple. It provides highly optimized data structures, strings, lists, hashes, sets, sorted sets, bitmaps. These structures live directly in memory. Access is often O of 1, meaning the lookup time remains nearly constant. Whether you have 100 users, 10,000 users, 10 million users, Redis can often find data almost instantly. Next point is no complex query engine. Imagine asking SQL, join these 5 tables, filter these records, sort the result, group by country. A relational database has to do a lot of work. Redis doesn't try to be everything. Redis focuses on speed. Most operation looks like get user 100, set user 100, incr page views, increment page views, lpush notification, simple command, simple operation, less work, more speed. Next is Redis is single threaded and that makes it more faster. This sounds backward. Most people think more threads, more speed. Not always. Imagine 10 people trying to edit the same document. They constantly block each other, wait for locks, fight for resources. Synchronization becomes expensive. Many databases spend significant time managing concurrency. Redis took a different approach. For years, Redis used a mostly single-threaded execution model. One command executes, then the next, then the next. No locking, no thread contention, no deadlocks, no synchronization overhead. Because RAM operations are already extremely fast, this design works surprisingly well. Next point is Redis minimizes network overhead. Redis uses a lightweight protocol. Commands are tiny, responses are tiny. Example, set user 1 equal to Yogesh. Response, okay, that's it. No giant XML, no heavy payload, no complex communication layers. The amount of work per request stays extremely small. Next part is Redis avoids random disk access. Let's compare traditional databases. Receive query, check indexes, read pages from disk, load into memory, return result. Redis, receive query, look inside RAM, return result, done. Many requests completes in microseconds. That's why Redis often handles hundreds of thousands or even millions of operations per second. Next point is why Redis is perfect for caching. Imagine your application asks, show user profile. Every request hits the database. Thousands of users, thousands of database queries. Your database becomes overloaded. Instead, First request database to Redis. Redis store the results. Future requests, Redis answer them immediately. No database query needed. This is called caching, and it is one of the Redis most common use cases. Now, why big tech loves Redis? Redis is commonly used for session storage, user authentication, shopping cart, API rate limiting, leaderboards, real-time analytics, caching, gaming system, messaging system. Whenever speed matters, Redis often appears. Now the hidden cost of using Redis, the trade-offs. Now Redis sound perfect, fast, simple, microsecond latency. So why doesn't everyone store everything in Redis? Because speed comes with trade-offs. First trade-off is RAM is expensive. This is a Redis biggest limitation. RAM is dramatically more expensive than disk. Let's imagine 10 TB of SSD storage, affordable. 10 TB of RAM, very expensive. Keeping everything in memory provides speed, but that speed comes at cost literally. Next trade-off is memory is limited. Disk can easily store 10 TB, 50 TB, 100 TB. RAM is much smaller. Most Redis deployments store only hot data, frequently accessed data, not the entire company's data. Redis often work alongside a database rather than replacing it. Next trade-off is risk of data loss. RAM is volatile. Power goes out, RAM forgets everything. Redis provides durability mechanism like RDB snapshot, AOF assistant. But this mechanism introduces another trade-offs. You must choose between more speed or more durability. Fourth trade-off is not great for complex queries. Imagine asking, show all customers from India who purchase products worth more than 50k during a last 12 months and sort them by city. Relational database excel here. Redis does not. Redis is optimized for fast key value access, not complex analytical query. Fifth trade-off is scaling can be hard. Initially Redis is simple. One server, everything works. Then data grows. Now you need sharding, replication, cluster management, rebalancing. Distributed Redis becomes more complicated. Sixth trade-off is memory fragmentation. Over time, data get inserted, data get deleted, data get updated. Memory becomes fragmented. The result, Redis may consume more memory than expected. At massive scale, this becomes an important operational concern. Trade-off 7 is cache invalidation is hard. One of the famous joke in software engineering says there are only two hard things in computer science: cache invalidation and naming things. Imagine user updates profile picture, database updates, Redis still contain old data. Users see stale information. Now you must carefully manage cache expiration and invalidation. This sounds simple. In practice, it can become surprisingly difficult. Next trade-off is Redis is not a full database replacement. Many beginners think Redis is faster than SQL, so I will replace my database. This is usually a mistake. Redis and SQL solves different problems. SQL database optimized for durability, relationship, transaction, complex queries. However, Redis optimizes speed, low latency, caching, real-time access. The smartest system use both. If I want to give you a real-world analogy, then understand this. Imagine a restaurant, traditional database, ingredients stored in a warehouse across town. Every order requires a trip. But for Redis, most used ingredient already sit beside the chef. Cooking start immediately. That's Redis. It's fast because the data is already where it's needed. Now, why companies use both Redis and databases? A common architecture looks like this. User request comes in. It hits Redis cache. If found, returns immediately from there. If not found, it will go database query way, store results in Redis, return results. This combines Redis speed plus database reliability, best of both worlds. So the conclusion is why Redis insanely fast, because Redis keeps data in RAM and eliminates the biggest bottleneck in computing, that is disk access. It achieves incredible high speed through in-memory storage, optimized data structures, simple commands, minimal overhead, lightweight networking, and efficient architecture. But those advantages comes with trade-offs. Those are expensive RAM, limited storage, durability challenges, difficult cache invalidations, limited query capabilities, scaling complexity. And that's the key engineering lesson. Redis is not fast because it's magical. Redis is fast because it chooses speed over things that slower database spend time doing. Every technology is a collection of trade-offs. Redis simply makes the trade-offs that matter when milliseconds are too slow and microseconds matter. And that's why Redis became one of the most important technologies in the modern system design.